Hello students, in this class we are going to learn about the surface area and volume of another 3D solid, which is a cone. Let us first take a look at the conical shaped object. Here I am trying to show you a conical shaped object. Have a look at this object. You may consider this is a conical shaped object. Just take a proper look at it. If I take cross section of this particular object, the cross sections are not uniform. Remember, it was uniform in case of cylinder, but in this case the cross sections are not uniform. If I take the cross section of the cone, horizontal cross sections, the cross sections will look circular, but the circles will be of decreasing radius as you gradually move towards the top of it, and ultimately it will end in a point. Alright, now how many surfaces does it have? Watch carefully. It has two surfaces. One curved surface, this is the curved surface of the cone, and there is a flat surface which is a circular surface. So it has two surfaces. Once again, this is the curved surface of the cone and this is the flat surface of the cone. The flat surface is circular. Remember that there is no surface at the top, because the top ends in a point and point doesn't have any area. Alright, so let me try to draw this figure now in the two-dimension plane. As I have already told you that you cannot draw any 3D object properly on the two-dimension plane, but we can have a rough idea once we understand how actually the object looks like. Here is a cone. So there is the diagram of a cone you can see. Since the radius of the cone is, as you move towards the upper part of the cone, the radius of the circles are of decreasing radius, we say let R be the radius of the base of the cone and H is the height of the cone. This is right angle. This is why it is called also a right circular cone. So these H and R actually are the two parameters with which the cone is defined. And we can have a related quantity in this case known as the slant height of the cone. This one is the slant height of the cone, which is named as L. And L is not an independent quantity. You can apply Pythagoras theorem and find out that L is equal to root over R square plus H square. So these are the three things which we'll use. R, H and L. Once again, let me tell you, R is the radius of the base of the cone, H is the height of the cone, and L is the slant height of the cone. Now it has two surfaces. One of them is the curved surface. Area of the curved surface of the cone is pi RL, and area of the total surface of the cone. Remember that there is a curved surface and a circular base. So total surface area will be pi RL plus the area of the circle at the base, which is pi R square. So what is the total surface area of the cone? Pi RL plus pi R square. And volume of the cone is represented as 1/3 pi R square H. So that's all about the surface area and volume of a cone.